Welcome to Lesson 11, Factoring Expressions. Okay, we are going to try to go quickly through this lesson because there's quite a bit, but I like to walk you through your examples so hopefully you can answer these problems, know your problem set questions without any problem. So today, please write this under Lesson 11. Today I will model and write equivalent expressions using the distributive property. You're going to learn about distributive property. On page S48, you see this model. Okay, you have two boxes with 5s, and that's 2 times 5, and two boxes of 3s, and that's 2 times 3. How many 5s are in the model, and how many 3s are in the model? As you can see, there are 2 of each, correct? To write this answer down. Remember, even though I am talking you through this, make sure you're writing your answers down. Now, continuing on, what does the expression represent in words? Think about this. So if you want to, pause this and see if you can write it on your own. So, what does the expression represent in words? It means the sum of two groups of 5 and two groups of 3s. Because in order to find how much this bar is worth, you are going to have to multiply these two plus multiply the product of these two. So what expression could we write to represent the model? 2 times 5 plus 2 times 3. Okay. Now we have our bar has been rearranged, and here we have 5 plus 3 and another group of 5 plus 3. How many 5s are in the model and how many 3s are in the model? Okay, as you can probably see, there are 2 of each. Moving on, what does the expression represent in words? Think about it. Pause if you need to, and write down your answer if you want to. Now, what does the expression represent in words? It means that there are 2 groups of the sum of 5 and 3. Right? Sum is the answer for an addition problem, so 5 plus 3 and 5 plus 3, and there's 2 groups of these right here. What expression could we write to represent the model? We can write it 2 ways. This can be written as 5 plus 3, and they are put in quotation marks to show that this is one group, plus 5 plus 3, and that's another set of quotation, not quotation marks, but parentheses. That's put in parentheses to show another group. Or there's 2 of these, so you can just say 2 times the sum of 5 plus 3. Is the model in part A, here, as I can show here, equivalent to the model in part B, as we show right here? What do you think? Write down your answer. Pause this video if you need to. So yes, they are equivalent because both expressions have 2 5s and 2 3s. Therefore, 2 times 5 plus 2 times 3 is the same as 2 times the sum of 5 plus 3. What relationship do we see happening on either side of this equal sign? So we see that on the left-hand side, 2 is being multiplied by 5, and then by 3 before adding the products together. On the right-hand side here, the 5 and 3 are added first, right? Because that's, remember, PEMDAS? And then multiplied by 2. Remember PEMDAS, you multiply what's inside the parentheses first. In grade 5 and in module 2 of this year, you have used similar reasoning to solve problems. What is the name of the property that is used to say that 2 times 5 plus 3 is the same as 2 times 5 plus 2 times 3? Okay, the name of the property is the distributive property. The reason why it's called the distributive property is because it looks like you are distributing this 2 to the numbers that are inside here. So is 2 times 5 plus 2 times 3. Okay? That's why this is called the distributive property. So you're distributing the 2. Now we'll take a look at an example with variables. Discuss the questions with your partners. If you'd like to pause right here, pause it now. You can work on this with a partner. So what does the model represent in words? Okay. This means that A plus B plus B, or 2A's plus 2B's. And this can also be 2 times A plus 2 times B. What does 2A mean? What does this 2A mean? That means 2A means that there are, 2 A's, or it means 2 times A. Okay. How many A's are in the model? There are 2, right? 1, 2, and how many B's? 2. Now, what expression could we write to represent the model? Remember, we have this A plus B, A plus B. Okay, this can be written as 2A, 2 times A, plus 2 times B. How many A's are in an expression? There are 2. And how many B's in an expression? There are 2. What expression could we write to represent the model? Okay, this can be written as A plus B plus A plus B, or it can also mean, and it's the same as 2 times the sum of A plus B. Okay, because we have one group here and one group here. That means you 2 of those. You're multiplying it together. Are the 2 expressions equivalent? Remember our previous slides? Yes, because both models include 2 A's and 2 B's. Therefore, 2A plus 2B is the same as 2 the sum of A plus B. Okay, those are equal because it looks like because of distributive property, this looks like you've distributed the 2, right? 2A, 2 times A is 2A, plus 2 times B is 2B. Now we're going to use greatest common factor, use GCF and the distributive property to write equivalent expressions. We're almost there, guys. What is the question asking us to do? Okay, it's telling us that this looks like this. 3F plus 3G looks like 3 times F plus G. It's like you extracted the 3 and put it on the outside. Okay, so we need to rewrite the expression as an equivalent expression in factored form. So you've factored it, which means the expression is written as a product of factors. What does that even mean? The number outside the parentheses is the greatest common factor. Okay, so this is your greatest common factor. So this is written as a product of factors. So 3 times F plus G. How would problem 1 look if we expanded each term? How would this look like if we expanded each term? That would look like 3 times F plus 3 times G. What is the greatest common factor in problem 1? Remember, we had this 3 times the sum of F plus G. And you were told that the greatest common factor is this number out here. So the answer is 3. How can we use the greatest common factor to rewrite this expression? How can we? Think about it. So the 3 goes on the outside and F plus G will go inside the parentheses. So 3 times F plus G. You already wrote that, right? So number 2, use greatest common factor in the distributive property to write equivalent expressions. So look at this. We have 6x plus 9y. So we have 2 different numbers now. But look for their greatest common factor. Okay, you have different strategies that you can use to find greatest common factor. But just looking at it, what is the one number that goes into both 6 and 9? Okay, so we need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as a product of 2 factors. Okay, we need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as a product of factors. Remember, that just means you're multiplying something. So we're multiplying one number to a group of terms. So the number outside of the parentheses is the greatest common factor. How would problem 2 look if we expanded each term? So these two, 6x plus 9y, can be expanded to look like this. 2 times 3 times x plus 3 times 3 times y. So you can see this is where you can find your greatest common factor, right? What are the two terms that you see in both sides of the addition symbol? Oops. Uh-oh. Okay, so this is how we look like expanded each term. So what is the greatest common factor in problem 2? Remember back here I told you to look at what number you see on both sides. Okay, the greatest common factor is 3. How can we use the greatest common factor to rewrite this expression? Okay, remember your greatest common factor goes on the outside of the parentheses. And what are you left with? So I will factor out the 3 from both terms and place it in front of the parentheses. Alright, this greatest common factor goes on the outside. I will place what's left in the terms inside the parentheses. 2x plus 3y. And now you're like, Miss Caldwell, where did you get the 2x plus 3y? Well, I got that back here. Remember, so I just took this 3 out. Now you have 2x. I took another 3 out, and you're left with 3y. So that's why this is 3, the greatest common factor, times 2x plus 3y. Now, to check this, and we don't do enough of this, I really feel that this is an important part. If you were to distribute this 3, meaning you would multiply it to this term and then you multiply it to this term, 3 times 2 is 6x. 3 times 3 is 9y. And that's how you know you have the correct answer. All right, number 3. 3c plus 11c. Now, is there a greatest common factor in problem 3? Think about it. Think about it. No. Yes, there is a greatest common factor, right? When I expand, I can see that each term has a common factor c. So, my friends, it is not always going to be a number. Okay, so 3 times 3 plus 11, 3 times c plus 11 times c. You see that your greatest common factor is the letter C. You're going to rewrite that. You're going to put the C on the outside of the parentheses. The C plus, and extract that. You're going to take that and put it on the outside. And you're left with 3 plus 11. So C times the sum of 3 plus 11. Okay, and that is how that one works. Number 4, use the greatest common factor and distributive property. Okay, now you have 24b plus 8. Look at this term. You have one with a variable and one without a variable. So your coefficient here is 24, and your number here is 8. Explain how you use G's greatest common factor and the distributive property to rewrite the expression in problem 4. Okay, you can pause here, work on it with your partner, and then resume the video. So, the way this goes is that first you can expand each term. I know that 8 goes into 24, right? 8 goes into both this and this. So I use it in expansion. 2 times 2 times 2, because does that. 2 times 2 is 4. 4 times 2 is 8 times 3, which is 24, times b. And here is 2 times 2 times 2. I determined that 2 times 2 times 2, or 8, is the common factor. So on the outside of the parentheses, I wrote 8. And on the inside, I wrote the leftover factor. 8 divided by 8, right? Your quotient is 1. So you are left with 3b plus 1. So 8 times the sum of 3b plus 1. When you distribute this, okay, you distribute 8 times 3 is 24b plus 8 times 1 is 8. You'll find you have the correct answer. Why is there a 1 in the parentheses? Think about this. Write down what you think. So there's a 1 in the parentheses because when I factor out a number, I am leaving behind the other factor that multiplies to make the original number. Because you need something in there. Okay, otherwise, there's nothing to add to. In this case, when I factor out an 8 from an 8, I'm left with a 1 because 8 times 1 is 8. How is this related to the first two examples? Is it related? Okay. In the first two examples, we saw that we could rewrite the expressions by thinking about groups. We can either think of 24b plus 8 as 8 groups of 3b and 8 groups of 1, or as 8 groups of the sum of 3b plus 1. This shows that 8, come on, disappear. Okay, 8 times 3b plus 8 times 1 equals 8 times the sum of 3b plus 1 is the same as 24b plus 8. I know that's long, but it's really important. So, today you learned about an expression in factored form is an expression that is a product of two or more expressions is said to be in factored form. Your next steps. With a partner by yourself, solve exercises 1 to 2 and the problem set questions. Yes, you do need to do the problem set questions. When you are done, get an exit ticket. If you need help, write your name on the board. Let me know what you need. Until next lesson. All right. See you guys.